Music theory, OneNote presentation looking at the notes in the musical alphabet, giving them a practical numbering system. So get ready and some coffee because we're rocking with OneNote, but it's a beautiful note. We are in OneNote, noting that although you're not required to, if you have access to this OneNote file and would like to follow along with us, we're in file name, modal node system, MNS, in presentation 1110 Excel notes and numbering system, the only presentation we currently have, but we plan on adding plenty more to this file shortly. Also note that we're going to work most of these presentations as well in Excel, focusing more of our time on actually building the tables and therefore possibly a little less time on the theory stuff. More time on the theory stuff here then, hopefully. However, I highly recommend actually building these tables in Excel because, like playing the guitar with your actual fingertips, you get that tactile feel that helps you to actually visualize the table, make them less abstract as well. So what we want to do this time is look at the normal numbering system that's going to be in our music theory, or the normal note naming system in our music theory. Think about why we would want to be putting in play a numbering system and how that might be helpful as we start to build on the ideas and concepts. In other words, build scales and build chords from this baseline, keeping in mind my major instrument that I'm going to be thinking about is the fretboard, although the same concepts do apply to all other instruments, including even the piano. I say even the piano because, like I say, us guitarists get jealous of the music theory oftentimes possibly being constructed with the piano at hand instead of the guitar in hand. But I even think that that could cause problems on the piano side of things, right? Because it still causes some issues that we have to kind of unlearn things when we learn things just because of the natural construction of the piano and the language. And those are the things that I want to keep on reiterating as we go kind of down the rabbit hole. I think that the general idea that I want to keep on reiterating is, if we built the system today, would we build a different system than the one that has been constructed as it has been built on top of each other over time? I think the answer to that is clearly yes, we would, if we were starting from scratch and didn't have the historical baggage, which then leads us to the question of, should I learn things in a faster, more efficient system because it'll be faster, but then I'll have to bridge the gap for communication purposes to the system that I'm currently in? My argument is always basically going to be yes, almost all the time. It's going to be better to learn faster and then bridge the gap back, particularly these days, given the resources that we have. So that's going to be the ideas that I'm going to keep in mind, noting that when I look at the fretboard, in particular, it's quite common these days for guitarists to learn in shapes. That's the natural way to learn the fretboard, which actually doesn't lend itself as easily to the numbering system, which is based on in scales. So I just want to keep leading into this idea as we learn these concepts and see why it is applicable. That means that most people learn the caged system. That's one thing that you're going to hear a lot about, meaning taking the open shapes in open position, moving them up in the fretboard. You might hear a lot about breaking the fretboard into 5 shapes that are putting together one master or giant shape, which is basically what we are looking at here. And those are the 5 positions that you could name with a caged system if you want. Bar chords is another way to just visualize the guitar in terms of shapes. So then when we convert that to language, though, we end up kind of having issues with the naming conventions of chords and with the interval naming convention, which wants us to rename every time we look at a particular point. So let me give you the general idea of this. If I learn this shape on the fretboard, which is one scale shape in the key of C, but which is completely copy and pastable, meaning maneuverable, that covers all 12 positions and all 7 times 12 positions with regards to the modes. So from a shape perspective, there's no argument really. I don't think anyone would argue that what you want to learn is this shape that you might then break down into 5 shapes or 3 note per string shapes or to a caged shape. But this shape that you can then move through the 12 positions. I don't think that's arguable. The question then is, how do I name each of the points within the shapes and the relative distances between them? The three methods we can do that is either we name the actual notes themselves, which works if you're playing in the key of C, just like playing all the white keys on the piano works if you only play in the key of C and related modes. 7 modes, not just the key of C major, 7 modes. But it doesn't work if you play in any other key and the 7 modes. So you've got 7 times 11 that it's not going to work in because I can't shift the shape up that way. That's the problem. Same problem you have on the piano. You can play all the white keys. It sounds cool. You don't need to even know what you're doing. You could just play rhythm. It's great. Super cool thing to do. But if you want to play in anything other than the key of C, you're not going to know how to add the other notes in if you don't understand why the key of C was put together the way the key of C. Then you have to, that's why the piano can kind of also mess people up to some degree, the way it's kind of laid out. It's really nice if you just play in the key of C, but then it becomes a little bit wonky to unlearn things when you're trying to see how to play other and apply the other shapes, which we'll see here. Now you can also think about relative scale degrees. That's more maneuverable. So what they did is they said, okay, well, let's number the system as a scale of 1 through 7. So the 1st through the 7th. Now, if I'm playing in the key of C, that's great because if I move up to a G or something, then I can shift the whole shape up and the shape now is copy and pasteable. Problem, however, I can't move that system to play in another related mode, like the minor scale, for example, because then it wants me to renumber the system. So I can't go through the 7 modes that way without renumbering the same shape. That's inefficient. What would be the most efficient way? To learn the modal points. I want to learn the modal points and memorize those because those are good for the modes and they're good for shifting. That's what you are in essence doing when you're memorizing by shape. You're memorizing all the nodal points. All you want to do then is name those nodal points. And that'll give you the modes. And then you want to look at the distances between the modal points. That'll give you the distances, or which we call the scale degrees. And so that's the general idea that we'll get into. All right. So let's think about the notes then normally. How is the normal convention of the notes? We've got an A, you've got A through G, right? What normally happened, or how did they do this? If you think of the piano, you can think of the scale of 7 notes. They put the 7 notes on. You can just imagine the black keys aren't there, and they just said 7 notes. Now, I just want to imagine. I'm not saying this is exactly what happened, but I want to try to imagine what happened like you would do if you're looking at a system that doesn't look quite right, and you're trying to say, what were they thinking? Like if I'm an accountant and I see a chart of accounts that's all messed up, then I want to go back and try to get in their mind and say, how did this progress? How did this possibly happen? And I'm thinking that they were probably saying, hey, look, I'm trying to teach people who possibly aren't going to advance that much in music, that maybe they're singing and things like that, and I just want to have one key where everything sounds good in one key. So and I'm just going to pick a key, with the key of C, and I'm going to make an instrument where I can play everything with a nice keyboard, and I'm going to ignore everything except the key of C and the related modes. And all the related modes are similar. They're all parallel constructions. So that would make sense if that's what you wanted to do, right? So then you got A through G, even though C is kind of like the main key that we think about as the major. But then you wanted to add the other notes, but you couldn't add the other notes. That's like creating a numbering system for your general ledger accounts of 1 through 7, and then realizing that you need 12 notes. I have to stick in the other notes, but I can't because I don't have a position between them. I would have to use like a 0.5, but you can't use a 0.5 if you use letters because there is no 0.5. So I have to put something in between it. So that's what happened here between A and B. These are the notes that are in the key of C. I had to stick something in between it. So what am I going to stick in between it? I can't call it an A.5, so I'm going to call it an A sharp. So I can call it basically an A sharp. Now notice if I call it an A sharp, what's going to be the argument? Well, why is it an A sharp? It's halfway between an A and a B. It's as close to the B as it is to the A. So why would I have two A's then? I should sometimes call it a B flat, right? So now we have this system of, well, it's sometimes going to be an A sharp and sometimes a B flat because it should be like a 1.5. But now we have to say an A sharp or a B flat. Now, when might we use an A sharp or a B flat? Well, you don't want two A's next to each other because that would be looking messy if you're trying to write things by hand and people have bad handwriting and stuff. So oftentimes when you're spelling things out, you can choose either of these notes, right? And what you're usually trying to do is avoid having two of the same note, right? You're usually saying, I don't want two A's next to each other, therefore I'm going to make this one, which would be an A sharp, a B flat. That's what ends up happening. Or as a general rule, when we're counting up in pitch, down in terms of the way I've listed it here, then we go, then usually we're going to go to a sharp, A sharp, B, and so on. And when we're going backwards, as a general rule, we want to go B flat, A. Now, so that's going to be, you can see logically kind of how that happened, but let me just list out, obviously that causes all kind of problems, right? Now, the other thing that's kind of cool about that, however, is that we start to see patterns in the system. So if I start looking at the circle of fifths, for example, and I start building out scales, I start to realize, hey, look, I can build all of my 7-note scales out of the 12 notes with every letter in the alphabet, A through G. And isn't that cool? And it's like, well, that's cool. Well, but the only way I was able to do that is to say that I don't want two notes next to each other. So I had to nudge all of the notes to be either a sharp or a flat. So do you see, you come up with cool things, patterns that you're seeing in the system, even though the system is overly complex, in part because it's laying on top of something that's symmetrical, right? You're looking at just a numbering system of 1 through 12, and then we put this kind of weird pattern on top of it, which is going to generate interesting, weird patterns once we start to analyze it, such as all the notes having this one letter, and then we can kind of see the pattern for the sharps and the flats, how many sharps and flats are going to be in each scale. If we look at C major, D major, and so on and so forth, interesting patterns. However, it's really unrefutable. I mean, put it into a ChatGTP or some kind of logic-based system and ask the question from just simply a system-based system, are the benefits of this sharp flat system outweighing the cons? And I think, and tell me why. And I think, and again, it's not just me, it'll list it out. Give me the history of it. Just give me the history. It'll list it out. It's beautiful. And you'll be able to, and so it's not just me saying it. I mean, I think it's just clearly a fact that it's not the most efficient system, right? So the things that we want to be aware of then is that when we look at a piano, it's so cool that you can play just the white keys. I used to do this as a kid when people left the house, so they don't make fun of me, right? It's because I don't really know what I'm doing. But I can like tap on the piano and I could make different rhythms as long as you're in the key of C. That's great because then you can focus on rhythm and stuff like that. But you have to kind of unlearn that to some degree to then realize what's really happening is you've got 12 notes that are all the same, and they've already picked 7 notes using the formula. Okay, so let's keep going. We're going to go from B. So then we have what we call a natural half step between B and C. Again, this is not really natural. It's only natural because the key of C was made first, right? If we had 12 notes and we just applied the formula to any of the notes, the half step might lie anywhere. So again, this is another kind of problem that is a result that shouldn't be. It's leading us to a presumptions that is not exactly right, which we can rectify with a numbering system where we can clearly see that all these notes are simply evenly spaced, numbered 1 through 12, right? And then we have a C sharp, and then we have a D, And then we've got the D sharp. Now notice that that C could also be called a D. If we're going the other way, it would be a D flat. And then we've got the D, and then we've got either a D sharp or an E flat. Also note that these little hashtags, this looks like it's a hashtag, but it's actually a number sign for music. This is another thing that I just want to point out, because I really think that there's something to the idea of this kind of aristocratic like mindset when this stuff was basically coming about. Maybe not, maybe, but you if you're trying to build something that's kind of like an elite thing like music, you might come up with symbols that aren't like normal symbols. Like this is kind of something that you might do if you're playing by hand. Obviously today we possibly would do something that fits in the computer. That's why we would want to do it, because then we can code it easier. But even back then, some of the squiggly lines they come up with and stuff, you're like, that does not seem like it's the easiest thing that you would do, right? It just doesn't seem like it. It seems like something that you might do on purpose to make it weird, right? But what we end up with today is, of course, when I'm trying to put this in the computer, I could just simply copy and paste that little symbol and copy and paste it. But what I'd like to do, of course, is come up with a symbol that is easily typable in the computer, that's not weird. I want a normal coding system, not because I'm trying to change everything, but just because that makes it accessible and easily computed, easily looked at, so I can focus my attention on music creation and not on the weirdness. Now, again, I know a lot of people, I'm not trying to put down like the tradition, like the tradition aspect of it. That's how it's always been done. It looks this way. I like the aesthetics of it. I get it. I mean, that's not my thing. That's not how I usually, but there is some of that that's reasonable. But from a systems perspective, that's what I'm going to keep on looking at, right? So then you've got the E, and then you go from E to F, you get that natural half step, which again is really only there because we had the C major scale first, which I'll talk about in a second. And then we get to F sharp or B flat, depending on if you're going up or down or what you're spelling. And then you get to G, and then finally G sharp or A flat. Why is it G sharp or A flat? Because there's only up to G sharp, and then it goes back around to A. Now, this is the other thing that we want to kind of keep in mind here, is that the actual system is looking like this. We looked at this in a prior presentation, and notice this was created by AI, so it doesn't line up perfect, but this is the idea. We looked up in a prior presentation that in reality, what we have is a system that, like the number line, goes up infinitely, goes down infinitely in a line, but also repeats octave-wise. So visually, in a 3D format, you have a circular pattern like a clock, but also linear direction, that it goes infinitely up or down. We can't visualize that, not just you, not just me. I don't think Einstein can visualize this, right, consistently. What he can visualize himself riding next to a light wave, but not that. I don't know. But I don't know what Einstein can do. Maybe he could. But most of us have to visualize one or the other, linear or in a circle. So you can imagine if I keep on going linearly, I would keep on going up this way. It would start over to A, but now I'm in a different octave of A. Now again, I'm not really thinking I'm in a different octave. I'm just thinking pitch-wise, it's going kind of around in a circle, but it's repeating. But in reality, like number-wise, if we measure it, we're going up in octaves, right, directionally. So now we go back to A, and then A sharp, and it repeats, B, and so on, and we have the same kind of issue up here. So oh man, what did I do? So I've repeated it 2 times here. I want to delete that without it doing something funny. So I've repeated it 2 times here because that allows us to start on any note and apply the same pattern. All right, so there we have that. Now notice you can also, here it is in a circular pattern. So here's the A, B, B, C, C, D, and you can see it in a circle, and it just repeats. This way it's more like a clock format. I put the C on top because we're going to see it in the key of C. So you can see, again, obviously this numbering system is clearly not, from a system standpoint, what you would want to build the system on. You don't want to build a system on a set of of numbers that are all just simply equally spaced numbers, but then you created two names for the same exact thing all over the place, right? And when you start, and even these names aren't even constant all the time, because sometimes when you're naming something, you might call it like a B sharp or a C flat, even though we're saying there's not a natural B sharp or C flat. So you get all this weird stuff that's happening, which is crazy because that's like the baseline of your system. Everything is built on the 12 notes. And we've decided that the 12 notes are now going to have multiple names. That's madness, right? That's like there's no way that the pros can outweigh the cons of just having a numbering system. And again, I just want, like, obviously if you just count out the system, I can't even count it alphabetically upwards. I can't even say A, B, C, D, E, F, G because the sharps and flats are there. Now you might say, well, yeah, but you can do that on each of the scales. Isn't that cool? I can do each of the scales have A, B, C, D, E, F, G on all scales built off of all the notes. And it's like, yeah, well, that's cool until you realize that, well, then you have to memorize the number of sharps and flats, possibly by using the circle of fifths, and then you got to know where the sharps and flats lie on it. And sometimes you're going to sharpen flat even the notes that don't actually naturally have a sharp or a flat, like the B sharp and the C flat, because you don't want to have two B's or two. That's, see what that, the, no, no, that something is wrong with that, right? So so it's pretty clear that, and also you can't measure distance, obviously. So I can't just say, well, if I go from C down to A, how many half steps is that? We're in a system of half steps. These are all equally apart. They're all apart in equal distance. So I don't want it, but I can't, so you would think I would be able to say, if this was, I can number it. If this is a 4 minus the 1, I can get a distance of 3. But I can't really do that here. Even with simple distance going in an upward direction, I'm going to have to use my fingers to count up. And when I count up, I have to remember the sharps and flats. And when I'm counting backwards, I've got to remember the flats instead of the sharps, right? And if you count backwards, it's even worse. Just try counting the alphabet backwards, just from G to A. And answer me this: is it easier to do that or to count from 7 down to 1? It's a lot easier with numbers. Now and then add the sharps and flats in there. So now you have to add a flat and then know where the natural half step is, because they happen to put the natural half step on the key of C, right? It's madness that's the way, that's how you're trying to think when you're trying to measure a distance, that's the way you're thinking, right? So again, we can't really remove that, but we can clearly add numbers. We can clearly say, I'm going to add some numbering system. Now, how should the numbering system be based? You might say it should start at 0. If you're a coder, that's probably what you would do. And I'm sympathetic to that argument. Maybe that would be a better way to go, because you get this off by 1 system. I'm putting a 1. Why? Because I think it's just easier for normal people to say that the A is a 1. Now, notice the reason 0 might be used is because if you have a numbering system like a clock, then the clock starts at 0. And when you're going around in a circle, you want to count the distance from each node in the system, each point on the clock head, right? And then go back to 0. That's how you normally would do it if you're putting it in a code system. But like I said, to me, I've mapped the whole thing out and I don't really see a problem doing it this way. I do see that off by 1 issue when we start to get into scales and scale degrees. That's where I'm going to put it. But I can see the argument that you might say, if someone has a reason, maybe you can have a reason why that should be 0 and show me how it messes something important up. I'm not seeing it messing anything important up. And I think it's more intuitive to say that the A is the 1, although it gets thrown off right away because you would think B would be 2 if it was going to line up with the alphabet, and it's not because of the sharps and flats. Now, the other argument is you could say, well, C should be 1 or should be 0. The top of the clock head should be C. Now, why would it be C? Because that seems to be the key that historically we have picked. Why did we historically pick it? Who knows? That's just what they could have picked A, but they picked C. Okay, so C, so we should count it from C. So if C was the key that they historically picked, why didn't they call it A? I don't know. Again, plug it into ChatGTP. Maybe there's some rationale, but I'm sure it's not because they were picking the best system having all the current information and knowledge, right? So there's an argument that you could make the C one. But again, I think that's less intuitive if you're trying to give a numbering system that most people can see most clearly, right? I would think it would be easiest to start at 1A, that's why. But whatever the numbering system, notice how much cleaner the numbering system is. If I say the notes are 1 through 12, I know that they're all equal distances away. One note to another note is a half step. Half steps are like inches to us Americans, at least we don't have the metric system so much. And that's our standard unit of measure we can think. And there's 12 of them. So there's 12 equal inches. They're all the same. So that removes all this stuff that's actually incorrect of, well, the natural notes, the key of C major is somehow special or different. Those notes, or there's a natural half step between B and C. No, there's no natural half step between 3 and 4. It's the same distance. It's the same distance, right? So the only reason, so then we will apply the formula and derive from these 12 notes using a formula the key of C. But we can derive the same formula starting at any other note and come up with a scale that's just as valid theoretically as the scale of the key of C. So you can see, like if you're starting the system from scratch, what would you do? I have 12 units of measure, right? I have 12 equal things that are all an equal distance apart, which we call a half step. That's what we would want the baseline to be. It's just unquestionable, I feel like. And again, plug it into ChatGTP, plug it into anything, any kind of software. I think it's just unquestionable, right? So, and then we would want to basically build on that. Okay, so that means that we can't really get rid of the old system, right? Because that's still how we're going to visualize things. But you can certainly, as you're learning, add the numbering system on top of it, allowing yourself to code switch between the numbers and the letters, which gives you the capacity to do simple math, such as, what if we're on C going from A? The distance is 4 minus 1, or 3 half steps away. 1, 2, 3. 3 half steps away from the A. What if I'm going from 3 to 7? What if I'm going from the B to the D sharp, right? Well, I can take 7 minus 3, 4 steps away. 1, 2, 3, 4. Do I count the 3 when I measure distance? No, which is a problem that comes up later when we do scales. They want to make this like the 1. No, you count after the 3, right? And I want to keep on reiterating this because this is the other problem we're going to run into. The scales are renaming as though we have to count this as the 1 in order to count from it, in order to measure distance, right? That's weird. That again, this is my analogy I'm going to keep on coming back to. You have a basketball hoop that's 10 feet high. You have a kid that's 3 feet tall. You're trying to find the distance from the kid to the top of the basketball hoop, but you measure from the kid's chin, and you say, well, if I say that his head is foot number 1, it's 8 feet to get to the top of the basketball hoop. So it's like, no, it's not 8 feet. You don't count his head as you count from the top of his head. From the top of his head. You measure from there, right? And we'll run into that kind of problem when we get into scales. And I think it's just unrefutable that is weird to do. Okay, so then if we have this, notice what I would like to do then is say, look, I don't want these funny sharp, if I'm putting this into a computer code system, and remember, you might say, well, I'm not doing computer code. I play guitar as a musician. I'm not talking computer code. Well, yes, but notice that if the computer, like this is the thing that just drives me crazy. Like, it's like, this is how we're going to learn it. We're going to learn it this way. But when I plug it into the computer, I'm going to give the computer this numbering system. So what are we telling the computer? We're telling the computer, hey, look, computer, I'm going to let you do it the easy way with just a numbering system of 12 numbers so that you can give me the answer while I still, in my mind, do it the difficult way. Do you see that? That's crazy. If the computer is telling you, hey, look, I need the 12 notes. Why? Because that's the easy way to do it, you idiot. That's what the computer's saying. Why are you doing it? Why are you doing it this way, right? We're actually using the computer to do it the easy way, to tell us the answer of us doing something the hard, like going around the long distance. Why are we going the long distance and then using the computer just to do the short distance thing? Okay. But I also don't want I don't want these two names and I don't want the symbols, but I still want to see the letters. So what I'm going to do is I'm going to say when I get to the AB, I'm going to call it just ABs. That means when I put it in a cell over here, like in our fretboard, at this fretboard, all I can see are the ones that don't have sharps and flats. But when I put a sharp and flat in this cell, I don't want to say it's going to be A hashtag or B hashtag. That's going to take up the entire cell. That's too much. So what I want to do is make a shortcut. That's what I'm going to call AB. So uppercase for me is going to be the if it's an A, and then if it's either, you can call it, I don't care what you call it, an A sharp or a B flat, I'm going to call it an AB, which is the same numerically as like 1.5 for simplicity to type in Excel so that when we create our fretboard, it's easy to see and we can still name it either way. That means either A sharp or B flat for me. So again, I'm not sure if that's not a standard thing that people are doing, but if you're mapping it out on a fretboard and you're looking for a system that's going to be easy to see while still capturing the concept of it having two names, sharp or flat, that will work. So then we have a B, and then we've got the C, and then the C, D, the D, right? I'm just combining the number and the letter. So this is either a D or an E, and this is going to be an E. This is going to be an F. This is either going to be an F or a G, an F sharp or a G flat, and then right, a G, and then either a G sharp or an A flat. So that's going to be the system that I think is easiest just from a typing standpoint. And then what I'd like to do is combine these two together. I'm going to combine these two together so it's 1A. So when I put it in my fretboard over here, notice I actually flipped it. Like I was putting it in here as 1A. I think it's easier to see as A1. So I see it as note A, which I'm also going to call from a number standpoint 1. So I'm going to flip it around, but we did this with a formula by just saying this equals this cell and this cell, and we'll get into that Excel-wise if you want to look at how to do that. But now I can build my fretboard, and I can see all of the notes. And I'm only showing the notes that are in the key of C here, and I find that to be the most useful thing. If I populate all of the cells on the fretboard, it gets too busy looking, even though I can color code it to just show any notes that I want. So I figured out how to just show the notes of the key that I'm in, and I can switch the key on my fretboard in Excel, which is super cool. So even if you don't want to learn how to program the Excel, that is such a cool tool to use. Like the best, seriously. It's the best. I get a lot of people, but I tried to say that the Excel's the best, and that's like my most famous presentation these days, because people apparently that's offensive thing to say, that Excel's the best music theory. It is, okay? It is, all right? I stand by it. It's not hyperbole, okay? So then we can just combine these two together, and boom. So now we can plug those into our fretboard. So now we have a baseline, and hopefully we can, so what I'd like to see is be able to visualize it as cleanly as possible. It's just like a ruler. It's just got 12 notes. None of the notes are better than any other notes. It's just 12 notes. I can write them this way if I want to visualize the fact that some of them could be called sharps and flats. And now I have something that I can cleanly build on, which is what's going to happen later, which is we apply the formula. Once you have the 12 notes, Then you apply the formula, which if you're starting on the key of C, the formula goes starting here, whole step, half step, whole step, and then the next whole step could go down here, next octave up, or it could go around in a circle up here. All right, and then so it's going to be whole step or whole step, and then half step back home. Or if I'm going this way, whole step, half step, whole step, half step. That's the formula. So if you want to visualize it the right way, you have 12 even notes. It's not like the white notes on the piano are where you start. All the notes are the same. And then you apply the formula, which results in, if you start from the C note, which is just a random thing to do, you could have started from any note, that's when you get the 7 white notes on the piano. See, they're not special. They're all the same theoretically, right? I historically, they're special, okay? Because a lot of songs are written in the key of C. It's got a lot of, so that makes sense because the piano is a beautiful instrument. It's in the key of C, and, that's great. But theoretically, it's not, there's nothing, you see what I mean? So then down, and then I can see it in a circle here. So if I map this out on a circle, C, same formula. C, whole step to D, whole step to E, half step to F, whole step to G, whole step to A, whole step to B, half step back home. That's the formula. And it happens to work out from our perspective logistically, just as like an accountant, like when I'm trying to build things, it's great to work in the key of C because I know that it doesn't have any sharps and flats in it. So just because of the naming system now, we have this kind of internal control to use the key of C as our default because the naming convention is such that it doesn't have any of the sharps and flats. So if I can figure something out in the key of C, such as the fretboard here, I know that I can shift everything up to every other key, which will include sharps and flats, but and it's just as valid as everything else, but I can be fairly confident it's working because I worked it out in the key of C, which gives me a little bit of an internal control due to the sharps and flats thing. That's one reason we play in the key of C. And even the guitar, by the way, is kind of keyed more maybe to A minor, which is the related mode, which has all the same notes as the key of C. So even it is kind of tuned favoring the key of C. So again, when I say it's not special, it is, historically special. That's the key that a lot of people that we play a lot of songs in. Yes, but it's not special in terms of theory on how you build the system. There's nothing special about those notes. That's happened to be the key that was picked. Okay, so we'll get more. So what we're going to go on top next time is to take these notes and build our scales from, and then I want to memorize those nodes, and that's what we'll get in next time, nodes on top of these 12 notes.